Hi friends, in our previous tutorials we have discussed Python coding techniques which sets foundation for your ambition to become a good Python developer. Hope you'll be practicing all concepts on your own as well. Friends, you'll have a clear understanding only when you practice the tutorials yourself as we move forward. If you have any doubts or questions, you can always let us know in comment section of that tutorial. We'll try to resolve your problem as soon as possible. In the next few tutorials, we'll discuss some very important concepts of Python programming. Python as an object-oriented programming language. These concepts are fundamental to Python, but many developers feel lack of proper knowledge of these concepts. So we have come up with this series of tutorials to make you understand these important concepts. Like any other modern programming language, Python is also an object-oriented language. We can develop Python applications using OOPS concept. Object-Oriented Programming System, that is OOPS, is a programming paradigm based on the concept of objects that contain data and methods. The primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. It brings together data and its behavior, generally called as methods, in a single location, that is object, and makes it easier to understand how a program works. In this tutorial, we'll cover each and every details related to Python OOPS concept so that you can properly use these concepts during programming. These are some major aspects of an object-oriented programming language: object, class, inheritance, polymorphism, encapsulation, and data abstraction. Let's discuss each of them one by one. It's imperative to begin with objects, as object is fundamental to OOPS concept. An object is an instance of a class. It is a bundle of data. An object has two characteristics: its states and behavior. Behavior of an object is also called as methods of object. Let's take an example to understand it better. Consider a car as an object. It will have some color, model number, company or brand associated with it. As far as programming is concerned, all these details are called state of the object, car, and at the same time the tasks it can perform, like moving faster, slowing down, change of gears, etc., are behavior of any car. Technically, these are called methods of object car. Let's consider another example of a person. A person will have some physical properties like color, weight, height, or any other personal details like address, educational details, etc. These are called states of the object person, and the physical activities he or she can perform, like a person can walk, speak, sleep. These are called behavior or methods of a person as an object. Now after objects, let's come to class. A class is actually a collection of objects. It is a blueprint using which you can create any number of objects as you like. Technically, an object is an instance of class. Let's understand it with previous example of car. Suppose you have a class car, and using this class you create, say, 3 objects of a car with different properties. Let's say first car is of red color, model number XX1, type sedan. And second one is of color white, model number XX2, type van. And similarly, third car, say it is a sports car of color brown having model number XX3. So here you can see that the class car does not contain any car in itself. It is just a blueprint of the car using which we have instantiated 3 car objects with different states. That's how we use a class to create multiple objects. Hope you would have got an idea of object, class, and relation between them. Now let's discuss another OOPS concept, inheritance. Inheritance is the most important aspect of an object-oriented programming language, which simulates the real-world concept of inheritance. It specifies that the child object acquires all the properties and behaviors of the parent object. By using inheritance, we can create a class, say class B, which acquires all the properties and behavior of another class, say class A. The new class is known as a derived class or child class, and the one whose properties are acquired is known as base class or parent class. Inheritance provides the idea of reusability of code, and each child defines only those features separately that are unique to it Rest of the features can be inherited from the parent class. Let's understand it with an example. Suppose you have an existing class vehicle in your program, which have some methods like move fast, slow down, change gear, stop, etc. And you want to create two more classes, say car and bus, which will also have similar methods. So would you create two separate classes in such a scenario? No, it won't be a good idea. You would like to use existing methods rather than creating duplicate methods. That's where inheritance comes into picture. You can create two child classes, car and bus, from class vehicle. Then class vehicle will become parent class, and all the properties and behavior of parent class can be acquired by child classes bus and car. Now that we have understood inheritance, let's discuss polymorphism. Polymorphism contains two words, poly and morphs. Poly means many and morphism means form or shape. It means that the same function name can be used for creating different types of behavior. This makes programming more intuitive and easier. Polymorphism, along with inheritance, is the backbone of object-oriented programming. We have understood from inheritance that a child class inherits all the methods from the parent class. However, in some situations, the methods inherited from the parent class do not quite fit into the child class. In such cases, you'll have to re-implement those methods in the child class. For example, suppose you have a parent class animal having behavior speak, as all animals speak. If you create some child classes, say dogs, cats and lions, you know that a dog barks, a cat meows, and a lion roars. As these animals speak differently, parent class methods speak what fit here. Here the speak behavior is polymorphic in this sense and depends upon the type of animal. You'll have to re-implement method speak for each child class separately. You can say by using same method, that is speak, we have created three different forms of speech. That's what polymorphism means in OOPS concept. Now let's discuss another important aspect of object-oriented programming, encapsulation. Encapsulation is one of the fundamental concepts of OOPS. It suggests the idea of wrapping data and the methods that work on data within a single unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of data. Consider a real-life example of encapsulation. In an organization, there can be different departments like accounts departments, top leadership team, sales section, etc. The accounts section handles all the financial transactions and keeps record of all the data related to finance. Similarly, the sales section handles all the sales related activities and keeps record of all the sales. The top leadership handles all the business related activities and approves requests from lower rank associates. Now there may arise a situation when for some reason an official from the accounts section needs all the data about sales in a particular month. In this case, he is not allowed to directly access the data of the sales section. He will first have to contact senior leadership and then request them to provide permission to access that particular data. This is what encapsulation is. Once the top leadership approves request from account section, then only sales section can share the data. Here the data of the sales section and the employees that can manipulate them are wrapped under a single name sales section. An encapsulation also hides the data. In this example, the data of any of the section like sales or accounts are hidden from any other section. Now let's understand another OOPS concept, data abstraction. Data abstraction and encapsulation both are often used as synonyms. Both are complement to each other because data abstraction is achieved through encapsulation. Abstraction is a process where you show only relevant data and hide unnecessary details of an object from the user. Data abstraction is used to hide internal details and show only functionalities. Abstracting something means to give names to things so that the name captures the core of what a function or a whole program does. For example, when you log into your Amazon account online, you enter your email ID and password and press login, and you successfully enters into your personal account. But background activities like how the input data is sent to server, how it gets verified is all abstracted from you after you press login button. A car in itself is a well-defined object which is composed of several other smaller objects like a gearing system, steering mechanism, engine, which again have their own subsystems. But are we humans really worried about these technical details? The answer is no. For humans, car is one single object which can be managed by the help of its subsystems even if their internal details are not known. Well friends, that's all about theoretical knowledge of Python OOPS concept. From next tutorial onwards, we'll implement and understand these concepts through live coding. Thanks for watching the tutorial. If you have any questions or comments, please let us know in comment section. If you like this content and want to follow our next tutorials on Python OOP concepts, then please subscribe the channel and do not forget to press the bell icon so that you can instantly get a notification about a new tutorial.